Okay, this is our lesson 2 for chapter 11. This lesson is about the Pythagorean theorem, and this is one of my favorite things to teach, one of my favorite things to learn about. So let's get started. Our vocab, the Pythagorean theorem, is an equation used to find a missing side of a right triangle. I want you to really emphasize that this only works for right triangles. If we have an obtuse triangle or an acute triangle, we cannot use this process to find the missing side length. Two vocab words that are review for us. The first one is leg. Remember, every triangle has two legs. These are the two short sides of a triangle. In this lesson, they're going to form that right angle. So if you ever have a tough time figuring out which two sides are the shorter sides, look for the right angle, and the two sides that build it are the two legs. Okay, so I'm going to label this here. You should label it in the triangle in your notes as well. The other important triangle word for us today is hypotenuse. This is the longest side of a triangle. It sits across from the right angle. So if you're ever having a tough time finding the hypotenuse, look for that right angle and go across from it, and there it is. So here is our hypotenuse. All right, something we're going to add to each side for this lesson are three variables. I want you to add variable A at one leg, B at another leg, and C at the hypotenuse. These three variables will help us with the Pythagorean theorem. And the formula itself is A squared plus B squared equals C squared. Easy formula to remember, very easy. And it tells us that if we take these two lengths of the two legs and we square them and then we add them together, it's going to be the same number as if we square the hypotenuse. And we can use solving equations to help us find those missing sides. Okay, so we're going to do a really quick review of some chapter 6 stuff, solving equations. Remember, there are 3 S's in solving equations. First, we're going to simplify. Simplify is when we look for like terms and parentheses, and we handle them first. Okay. Next, we separate. Separate is a step that uses addition and subtraction, and that's to get our variable terms on the variable side and the constant terms on the constant side. Our third S is to solve. This is when we use the inverse operation to isolate the variable. At this stage in the past, we've been doing multiplication and division, but in this lesson, we're going to do a different operation to solve. So let's review those inverse operations. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. The inverse of division is multiplication. But now we have a new operation that we want to worry about, and that's the square. So let's say we have a variable squared, and we want to figure out what that variable is equal to. In order to undo the square, we have to use its inverse operation, which is the square root. Likewise, the inverse of the square root is a square. So this is one new set of inverse operations that you can add to your list. Let's get started. I've got 2 examples for you. These are examples from your notes, so feel free to just copy these right into your notes. The first one is a right triangle. It gives these 2 side lengths, 3 and 4, and here's our missing side. In order for us to get started, we want to know where's our A, where's our B, and where's our C. So remember, A and B are the legs. So since these 2 sides are the short sides and they form that right angle, they're going to be side A and side B. And that means that our long side is side C, the hypotenuse. So write your equation, A squared plus B squared equals C squared. We're always going to start off by writing the formula, and then we'll do some substituting. We're going to substitute 3 in for A. We're going to substitute 4 in for B. Remember, yes, it is important for me to see those parentheses. C is unknown, so we're going to leave it a variable. Now we follow our order of operations, or our simplify, separate, solve. We're going to do our exponents here. 3 squared is 9, 4 squared is 16, and c squared is still c squared. Still working on our 3 s's. We have not simplified this side yet. We've got like terms that need to be added together. 9 plus 16 is 25. C squared is still c squared. I'm going to get my train tracks in here. I should have had them in all along. Now, after the simplify step, we separate variable side, constant side. They're already separated for us for this one, so that's pretty lucky. So all we have to do is our third S, which is to solve. So we see our c over here, our variable. We want to get that to be a c, not a c squared. So the inverse of the square is a square root. Draw your square root there. And remember, whatever we do to one side has to be done to the other side to keep it balanced. So the square root of c squared is c. That was the purpose of doing that square root, to get rid of that little 2. The square root of 25 is 5, and that tells us that our c is 5 inches. Okay, so this is what it looks like when we're solving for the hypotenuse. We're going to end up with 2 values on the left-hand side. We're going to add them together after we square them, and then square root in the last step. Every time we find the hypotenuse, it looks this way. When we find a leg, like number 1b, it's going to look a tiny bit different. So make sure you really understand 1a before we move on to 1b, because it's going to look slightly different. 1b, we've got our 2 legs here forming the right angle. This is leg A, this is leg B. And across from the right angle is our hypotenuse, C. So we get a squared plus b squared equals c squared. And we are going to do some substituting. We're going to substitute 12 in for A. B is still a variable, so B stays B. And we're going to substitute 13 in for C. So you can already see where this equation looks a little different than it did last time. This time we have a variable and a constant on the same side. So we'll take care of that during our separate step. All right, so simplify, separate, solve. Let's do some simplifying first because we have those exponents there. 12 squared is 144. B squared stays b squared because it is a variable. 13 squared is 169. So our simplify step is finished. Now we have to separate variable side, constant side. This is the only side with variables, so it'll be our variable side. This is going to be our constant side. So look at our variable side. Which term does not belong? It's the 144. So we're going to subtract to get rid of the 144 and balance that out on the constant side as well. We're left with b squared on the variable side. 169 minus 144 is 25. Now we have to solve. Remember, to get rid of that tiny little 2, to get rid of the square, we have to square root. If we do it to the left side, we do it to the right side as well. Square root of b squared is b. Square root of 25 is 5. So our missing side length here is 5 meters. All answers do not end up being 5, don't worry. These two just happen to be very similar at the final step. You can see how this one differed from the last example. This is what it will look like anytime we are solving for a leg. Okay, so these are your 2 examples. You have a couple word problems to work on, so go ahead and finish those up. And that's the Pythagorean theorem.